Hello students, today we are going to see some more important questions in that one among disaccharide. How the disaccharide it is forming, what are disaccharides and what is the reaction takes place during the formation of disaccharide. What is the linkage is present in the disaccharide molecule and how about structure of disaccharides? What are the units are present in the disaccharides? All these questions are answerable through this session. Come on, let us go for it. Disaccharide. Two monosaccharides combine to form a disaccharide. Okay, two monosaccharide means like monosaccharide. Monosaccharide example, like we can say it is glucose, fructose, galactose. These are all we can say monosaccharide. So monosaccharide, that means it is a glucose, alpha glucose, beta glucose, like that. So naturally OH group will be available. So two monosaccharides means here OH, another monosaccharide, saccharide combine to form. So, what reaction takes place? Condensation reaction takes place. Condensation reaction takes place. So, during condensation reaction, what which will be eliminating means naturally water molecules will be eliminating. Condensation reaction means naturally what will be there? Elimination of water will be there. Okay, so what is the product you are getting? Of course you are getting disaccharide only. So monosaccharide, saccharide combined with oxygen. See this oxygen, another monosaccharide. Monosaccharide. So this is called disaccharide. This is called what it is? Disaccharide. Okay, now the linkage between these monosaccharide, what linkage? Oxygen which is connected with it. So the linkage which is called glycosidic linkage. Glycosidic linkage. Okay, so this you know very well, monosaccharide combined with another monosaccharide to form a disaccharide. So this is what is disaccharide? It is formation of two monosaccharides. What linkage between that disaccharide molecule? It is a glycosidic molecule. Come on, let us go examples of disaccharide. What are the units are available in that disaccharides? That means a monosaccharide units combined to form only disaccharide. Okay, then what is the linkage, where the position of the linkage, that point also we will go for it. First and foremost, examples of disaccharides. Okay, maltose we just take it. So maltose, what are the monosaccharide units are available? Alpha glucose. When I mention alpha glucose, you people will come to know very clearly where that OH will be there in that Haworth process. Okay, alpha glucose plus another alpha glucose. Okay, now alpha glucose is the monosaccharide, another alpha glucose, both combined together you are getting disaccharide which is called maltose. Okay, now what is that linkage, position of the linkage? So Haworth process, 6-membered ring in that C1 and C4. So these both the position which is connected and it is attached with that molecule. Okay, I'll just write that examples, then we will go for that Haworth structural formula. Okay, now the second one, lactose. So lactose, what are the units are available? Beta galactose. So lactose means you know where you will get that lactose, from the milk only you will get lactose. Maltose, where do we get? From the malt sugar we can get it. Okay, lactose. So this is a beta lactose plus alpha glucose. So the position where it has joined the linkage C1 and C4. Okay, now the next one, third one, sucrose. sucrose, you know very well, sucrose. What are the monosaccharides? I hope you are knowing that answer. Okay, so what are the monosaccharides? Glucose and fructose. So alpha glucose and beta fructose. So beta fructose, you know very well. Okay, so beta fructose. So what are the position? It is C1 and C2 position will be there because it is a five-membered ring connected with it. Six-membered ring means it is a carbon 4. Five-membered ring means carbon 2. Okay, well, drawing that structure now, you will come to know very clearly. Okay, hope you're clear with this. Okay, let us go and analyze the structures. That is a Harvard structure of the disaccharide. Hope you're clear with this. Now we are going to see that structural formula of maltose, that is disaccharide, one of the disaccharide. How about the structure of maltose? Alpha and beta. Alpha means alpha glucose and alpha glucose combined to form alpha maltose. The same way, alpha glucose and beta glucose combined to form, it's a beta maltose. Hope you know, remember that alpha, beta, glucose and fructose. Okay, now come on, let us go for it. So here what it is, the structural formula, we are going to write it. So here, as I am writing that six-membered ring, alpha glucose means OH should come where it has to come? It has to come to the below side of that hexagon. Here H, here H, OH, and then here OH and H, here H, OH, and then here CH2OH, and then H. This is connected with the oxygen. Okay, so this is alpha glucose. The same way, another alpha glucose. So here the same thing you can draw another one more. So here water molecules revealed. Okay, it's come out eliminating. Okay, H, OH. Here H, OH. Here OH, H. Here H, OH. And here CH2OH. And then H. This is connected with oxygen. Now, water molecules which is relieved. Okay, so here OH plus H combined together H2O. So naturally, what linkage will be there? Oxygen linkage will be there. So here, like this, which is connected. Okay, now this is alpha glucose. This is also alpha glucose. We can say what is this? This is alpha maltose. What structure it is? Harvard structure. Hope you understand where that is OH has come. OH comes down means it is a alpha glucose. The same way. Now here I wanted to mention here the position of that linkage. Where is that position? Carbon 1. Now for example here carbon 1, 2, 3, 4, 5 and 6. The same way here also carbon 1, 2, 3 and 4. So the linkage between that C1 and C4. So the linkage between C1 and C4 which is called alpha maltose. Now we are going to see beta maltose. It is so simple. Already we have gone through this and here beta maltose means alpha glucose plus beta glucose. Beta glucose where that OH will be coming, OH should come on the top. Rest of that it will be same. Okay, come on, let us go for it. Here six-membered ring. For that, here alpha glucose same. H, OH and then here H, OH, here OH, H, here H, OH and then CH2OH and then H here oxygen. Please don't forget to put it oxygen here. That is a mandatory. Okay, now here another beta glucose. You know how to write the beta glucose? Okay, now beta glucose OH should come on the top. That's all. OH, H. Here H, OH. Here OH, H. Here H, OH. And then here CH2OH. And then H. And then here oxygen. Okay, now the linkage between these two molecules, water relieving, no? the linkage between two molecules, that oxygen, which is linkage. Okay, so this linkage, what can we say to that? Glycosidic linkage. Glycosidic linkage. Okay, so glycosidic linkage. Here also, this is glycosidic linkage. Glycosidic linkage. Okay, now this is what I really know. So what do we call this formula, this structural formula? Beta maltose. This is alpha maltose and this is beta maltose. Now the position of the linkage, of course, the same way, carbon 1, 2, 3, 4, 5 and 6. So in that way here C1 and C4. So the same way 1, 2, 3, 4. Anyway, okay, so this is the linkage between C1 and C4. We can say it is actually beta maltose. You just remember this one. See what is the difference between this and this. You see? So very clearly you will come to know. Okay, now the next structural formula, actually this is a 3-mark question. Definitely it will be coming, and you see the trick where it is alpha glucose and beta glucose, how to write the structural formula, then it will be very easy. In my last video very clearly I have explained it, twice and thrice I have explained. Please watch that video so you will come to know very clear idea about it. The same way this also, alpha maltose and beta maltose. What is alpha maltose? It is alpha glucose plus alpha glucose, means we can say alpha maltose. So what is the structural formula of alpha maltose? That I have given. The same way beta maltose, means one alpha, the other beta combined together. And what is the position of the linkage? Position of that molecule C1 and C4. What is that linkage? That is glycosidic linkage. Hope you're clear with it. Okay, now the next one, lactose and sucrose. Those formula also we can see through Harvard structural formula. Now the second formula, it is lactose. You know what is the general formula of disaccharide? C12H22O11. How glucose and fructose general formula C6H12O6, the same way disaccharide general formula C12H22O11. Only the units, combination of units of monosaccharide will be vary. So naturally the linkage will be vary, so that naturally structural formula also will be vary. Okay, now what is it? Lactose of alpha and beta, we will see. Alpha lactose, the combination of monosaccharide, beta galactose plus alpha glucose. So, beta galactose, it's common for both, whether it is alpha lactose or beta lactose. Beta galactose, it is common. Okay, so beta galactose plus alpha glucose means you will get alpha lactose. The same way, beta lactose plus beta glucose, you will get beta lactose. Come on, let us go and identify the structural formula. Now, 6-membered ring like this only, but here they mention beta galactose. Galactose, it is actually what it is, aldehyde functional group only. So, OH group comes on the top. Beta means it will be top. Alpha means the OH should come down. Okay. Now, here OH, H, here H, OH, here OH, H, and here H, OH, and then here CH2OH, here H. Okay, now this is an oxygen linkage. Okay, now here this is beta galactose and here alpha glucose. So you know alpha glucose very well. So alpha glucose 6-membered ring. In this here OH, where it should come? It should come down. OH, H. Here H, OH, here OH, H, here H, OH, and then CH2OH, here H. That oxygen will be here. Okay, now we have to combine to release that water. Is it possible to release the water and forming that linkage? H2O it is there, but linkage between that oxygen, there is no. Only here and there. OH, here OH. So when we connect this, so naturally oxygen linkage will be there. So that is what the process that structural formula comes like this. Here linkage comes like this. Okay, so hope you're clear with it. So what is the linkage name? Glycosidic linkage. Yes, glycosidic linkage. Hope you're clear with it. Okay, now beta galactose and alpha glucose, you know very well. Now the next one, beta galactose and beta glucose. You know how to write the beta galactose and beta glucose? Here the same here. So beta galactose OH should come on top. OH, H, here what it is? H, OH, here OH, H, here H, OH, and here CH2OH, and H, here oxygen. The same way here, another one more. Beta glucose, you know how to write that beta glucose? Beta glucose, same. Here, beta galactose and beta glucose, both will be same here. OH, beta, because that OH should come on top. Okay, now here, H. Then here what it is? H, OH, and then here OH, H, and here H, OH, and then here CH2OH, and then H, here oxygen. Okay, now the linkage between, is it possible here I'm getting that linkage oxygen? No, it's not possible. Only this cross, okay. So this cross linkage will be there with that oxygen. Here like this, it will be there. Hope you're clear with that. So what is that linkage? This is glycosidic. Please don't forget to put that glycosidic linkage. And this is what it is, beta lactose. This is alpha lactose and beta lactose. So what is the difference between alpha lactose and beta lactose? See here, that main point here, you just write it. Here HOH, here OHH. That's all. Okay, now the linkage between C1 and C4. The same way here also, C1 and C4. The linkage between C1 and C4. Generally, choose the correct answer. Objective type questions also, they may ask that like this. Structural formula also they will give. And the position of the structural formula also they will give. Hope you're clear with it. Which is the glycosidic linkage? Whether this one or this one? Which is glycosidic linkage? This is the glycosidic linkage, the linkage between two monosaccharide, which is oxygen. It is there because here also oxygen is available. That's what purposely I asked. Hope you're clear with this. Okay, now the next one, sucrose, we are going to see. Sucrose, what it is? It is a glucose and fructose. Fructose, what we are going to take? It is a beta fructose. Okay, so that is a 5-membered ring. So 6-membered ring of aldose and 5-membered ring of ketose. So combined together, you are getting what it is, sucrose formula. Okay, come on, let us go and identify that one. The next one more, it is sucrose. Sucrose is also known as saccharose. It's a disaccharide. General formula C12H22O11. Common for all disaccharide C12H22O11. It's common. Only monosaccharide units are vary. Okay, come on here. What is that monosaccharide units? Alpha glucose and beta fructose. Alpha glucose, we can say alpha glucopyranose. Pyranose means a 6-membered ring, whereas beta fructofuranose. Furanose is 5-membered ring. Here 6-membered ring, that is 5-membered ring. Come on, write that. We can go for that structural formula of Howard. Here 6-membered ring of alpha glucose, we can go for it. Here 6-membered ring. Here in that OH will be down. Alpha means OH will be down. You remember in that way. So H, OH, and then here OH, H, here H, OH, and then here CH2OH, and then H, here oxygen. Okay, now this is alpha glucopyranose. Okay, now beta fructofuranose. So furanose, it is a 5-membered ring and beta OH should be there on the top. Okay, we'll write that structural formula only for the fructose. Okay, then here what it is? OH, CH2OH. Hope you remember the fructose furanose formula. Here fructofuranose. Here OH, H, here H, OH, and then here CH2OH, and then H. So this is fructofuranose formula. Okay, now we have to go for linkage. Where is that linkage? OH, water molecule, it has to release, and oxygen should be there in that linkage. But here there is no oxygen. But here, this corner, OH, it is there. But this has to come and join so that oxygen linkage will be there. Okay, releasing the water, so oxygen linkage will be there. Okay, so how to bring it? We can bring it over here only, straight down. Okay, so here 5-membered ring, 5-membered ring. Okay, now here what it is? OH. The same formula, I just bring it here. CH2OH, and here OH, H, here H, OH, and then here CH2OH, and then here H, here oxygen. That is very important. Okay, now let me rub out this because you may get confused. Okay, this OH connected with another OH. So water molecule releases. So water molecule releases means oxygen, one oxygen will be available. So that is the formation of linkage, glycosidic linkage. So this is carbon 1 and this is carbon 2. We can keep it. So what is the linkage? Carbon 1 and carbon 2. So the linkage between glucose and fructose, what is that linkage position is there? C1 and C2. Okay, now here what is that linkage? Glycosidic linkage. Glycosidic linkage. Okay, now this is actually, here I wanted to mention one more thing. Here there is no free aldehyde or keto group, but whereas maltose and lactose, we have seen that what it is, aldehyde, free aldehyde group was there, so it may use for what it is, reducing sugar. But whereas here this is non reducing sugar, it will not answer for tolerance reagent or filling solution. Okay. Here, sucrose in that alpha glucose and beta fructose, it does not have free aldehyde or keto group is available. So naturally, it is having non-reducing sugar, whereas lactose and maltose is having reducing sugar. Why? They are having free aldehyde group. So it will be answer for tolerance reagent and failing solution, whereas non-reducing sugar, this there is no free aldehyde or keto group, so it will not answer for tolerance reagent and failing solution. Okay, now they may ask the question, why sucrose, it's a non-reducing sugar, what is the reason? Hope you understand very clearly. Okay, now everyone will ask the same doubt. Here C1 and C2, how come C2 it is available? Here C1 starts from CH2OH, second carbon keto group. From the keto group only CHOH which is going to attach. So that is the reason here C2, this is C2, here C1 and this is C2. So what is that composition of that linkage? C1 and C2. Everyone will ask how come it is possible C2, because this CH2OH we used to forget. So that is the reason. So hope you understand why this is C2, because it starts from first carbon CH2OH, second one CHOH only it starts. Hope you remember in my last video very clearly the structural formula I have given. Hope you remember all these points. Okay, now let us go for another point. The next one more important question, inversion of cane sugar. It is a very important 2020 also they asked inversion of cane sugar, invert sugar, non-reducing sugar. It's common question. Okay, now come on, let us go. See here, sucrose, it is a dextrorotatory compound. Sucrose, well, going for hydrolysis, acid hydrolysis, you are getting glucose and fructose. Glucose, it is a dextrorotatory. Fructose, it is a levorotatory. Okay, come on, let us go for the C12, H22, O11. plus water. In that acid hydrolysis, what you will get? C6H12O6 plus C6H12O6. Okay, this is glucose and this is fructose. Okay, now this is dextrorotatory and this is levorotatory. So the sign will be changing. You know why? Through optical rotation. Okay, now here plus 52.5 degree, here minus 92.4 degree. Okay, now the sign will be varied due to that what it is optical rotation. So naturally that is dextrorotatory and levorotatory. So here that inversion of cane sugar, that is what we are saying, because in that this is actually what it is, sucrose. Sucrose is what compound? Dextrorotatory compound. So through hydrolysis, we are getting two different compounds, that is glucose and fructose. Generally, we say aldose and ketose. Here, what it is? Dextrorotatory, levorotatory. Here, the sign also will be changing. So that is what inversion of cane sugar. We are saying inversion. Okay. Hope you're clear with it. This is through optical rotation we are identifying. Hope you're clear. Okay, now let us go for the polysaccharide. As we are seeing monosaccharide, disaccharide, now we are going to see the polysaccharide. So, polysaccharide, number of monomer units combined to form a polysaccharide. So, here carbohydrates with a high molecular mass, that is very important point. High molecular mass obtained by repeated joining of monomer units by linkage between what it is, glycosidic linkage. Glycosidic linkage, you know very well what is glycosidic linkage. Even disaccharide, glycosidic linkage, two monosaccharides combined to form a disaccharide. Two monomers combined to form a disaccharide, that is what it is, linkage, glycosidic linkage. So here number of monomers combined with the glycosidic linkage, that is called polysaccharide. Okay, now here what are the main examples of polysaccharide? Starch, glycogen, cellulose. Okay, in our next class we are going to see all these examples and structural formula also we will see to that. Hope you're clear with it, whatever we have gone through. How was process of lactose, maltose and sucrose, inversion of cane sugar, and what is polysaccharide. These are all the points today we have gone through. Hope you're clear with it. Thanks for watching.